Hi, welcome to Photon Academy. In the previous session, we have seen about the resolution of vectors. Let us see in this session about the resultant of vectors. Let us see about the resultant calculation. Observe in the previous class, if a force is given, if this is x-axis and this is y-axis, this is origin. If a force is given, F is the force, theta is the angle the force is making with x-axis, then we can easily split this force F along horizontal direction and along vertical direction into the components. If a force is given, we can split it into component. If I write here, if a force is given, we can split into components and split into the components along x and y directions. X and y directions. Here, this is direction, this is y direction. That is fx and along y. Clear? This we have seen resolving of a force into component in the previous session. Clear? Now, observe the reverse case. Let us say that if this is x-axis and this is y-axis, this is origin. If a force is given along x-axis, Fx, if a force is given along x-axis as Fx and along y-axis as Fy, we can easily find out the resultant of these forces as F, acting an angle theta with respect to the x-axis. Now the clarity. A simple difference. Earlier session we have seen that if a force is given, you can easily split that force along x direction as well as along y direction into the components. Now it is reverse. If two forces are given, one force is along x-axis, Fx, and the other force is along y-axis, Fy, then we can easily find out the resultant of these two forces as F, acting at an angle theta with respect to the x-axis. Is it clear? Okay. Now, observe that here I am highlighting it. Highlighting. Let us say this is x-axis, this is y-axis, this is r-axis. Clear? Force along x-axis is given as Fx, along y-axis is given as F. And what was the resultant? The resultant is F force. Resultant of Fx sine Fy. Here I am writing. Resultant of Fx force and Fy force as F as F. And observe carefully. It is that F. It means F. F resultant is acting at an angle theta with respect to x axis. With respect to x axis. Clear? This is the theta. Okay. Now observe carefully. The resultant of Fx and Fy is F. This is known as magnitude. This is known as magnitude. And theta is known as its direction. The F vector having a magnitude F is acting at a direction of theta with respect to the x-axis. That means if this is a vector, then resultant will also be a vector. And that vector is having a magnitude of F acting its direction theta with respect to x-axis. Is it clear? Okay. Now, observe. To find out the resultant, of Fx in Fy, find out the resultant of Fx in the Fy. Clear? Here we are following a simple process. This is x-axis, this is y-axis, horizon. This is the given force Fx. This is given force Fy along y-axis. Now we are saying that this is resultant is F acting at an angle theta. Clear? Now with the help of Fx and Fy, this is Fx. Clear? This is Fy. Clear? Now I am forming a simple right angle triangle. I am projecting this Fy parallel here. Here I am projecting. This I am dropping as a parallel. This Fy is drawn as a parallel. Dropping perpendicular to x-axis. Dropping perpendicular to x-axis. Now, if I say O origin A B triangle OAB is a right angle triangle. triangle. OAB is a right angle triangle. In the right angle triangle, I am interested to find out OB. Okay, what is the, according to the Pythagoras theorem, what is the simple concept? Base square plus height square is equal to the hypotenuse square. That is the principle. So OB square is equal to OA square plus AB square. That is F square is equal to, what is OA? OA here magnitude is corresponding to the length of the vector. That is Fx square AB. AB is parallel to this y-axis. This is AB. Magnitude of AB is corresponding to the length of the vector. That is Fy square. So what is F? Finally, F becomes under root of Fx square plus Fy square. This is magnitude of vector. Magnitude of the vector under root of Fx square and Fx square. This is the resultant force of Fx and say very simple. To find out resultant is very simple. Provided a force along x is given, a force along y is given, construct a right angle triangle, and then use a simple concept of Pythagoras theorem. Then you will get magnitude. The resultant of vector is F of Fx square plus Fy. Okay. Clear? Now, this is the magnitude. That means resultant. Magnitude in the meaning is resultant vector. Okay. Now, I want to find out direction also. What is this direction? This is a vector having a magnitude of this. And it's having a direct vector should have magnitude as well as direction also. Its direction is theta. Theta is with respect to which? With respect to x-axis. Now, again, I am taking the help of this right angle triangle. In this right angle triangle, I am interested tan theta. What is tan theta? Opposite side AB by adjacent side OA. Tan theta is opposite side AB by adjacent side OA. Observe. This is x-axis. This is y-axis, origin. And this is triangle formed. This is theta. And here, this is F force. This is Fx. This is Fy. Here. Now, this is OAB triangle. OAB triangle. In this OAB triangle, in triangle, right angle triangle OAB, tan theta is opposite side AB. This opposite side is AB, adjacent side is OA. So tan theta is OB is Fy by OA is Fx. So theta is tan inverse of Fy by Fx. Fy by Fx with respect to which axis? With respect to x-axis. Clear? It is with respect to x. This is nothing but direction. Direction of vector. Direction of resultant. Yeah. Okay. That magnitude is under root of Fx square plus Fy square. Direction is this. Clear? Okay. Now, observe carefully that if I am summarizing, if a force is given, if a force F is given, you can, at an angle of theta, you can split into the components along x-axis and along y-axis, fx as Fy, horizontal component, vertical component. This is resolving into components, resolving in component along x-axis and y-axis. Okay, force F is given at an angle of theta with respect to x-axis. Then you can split that force F as horizontal component and vertical component. This is the one part, first part. Clear? What is the second part? The second part is reverse. If this is x-axis, if this is y-axis, if two forces are given along x-axis Fx, along y-axis Fy, this is origin. Now, now you can have the resultant in between them, that is F acting at an angle of theta, acting at an angle of theta. This is nothing but calculation of resultant, or simply finding out of resultant of given effects of given effects in Fy. Clear? And you know the magnitude I have quoted, as well as this direction also I have quoted. Clear? No. This is about a force or a vector given, and you are finding out along rectangular component. These are known as components are perpendicular to each other. Observe Fx along x-axis, Fy along y-axis. And this is also Fx along x-axis, Fy along y-axis are given, and resultant is in between them. Okay. These horizontal and vertical components, perpendicular directions, are known as rectangular components. Rectangular. Here. Now, let us see. Observe. Resultant of two vectors. Resultant of two vectors. A bar and B bar. A bar and B bar. Okay. With an angle between them is theta. Between them is theta. We are interested to find out resultant of two vectors A bar and B bar, and the angle between them is theta. Yeah. Let us say this is a bar vector. Let us say this is a B bar vector, and the angle between them is theta. That is it. The angle between them is theta. Okay. I am interested to find out the resultant of A bar and the B bar. The resultant of A bar and the B bar. Having angle between them is theta. Clear? Where does the resultant lie? The resultant lie in between these two. This is the resultant. This is resultant vector. The resultant vector is, let us say, R empty. The resultant. Okay. This is the resultant vector. Let us see how it can be found. And observe that the resultant vector, which is acting in between them, is making an angle, alpha with respect to x-axis. It's making an angle alpha with respect. Angle between two vectors is a bar and b bar is theta. And resultant is lying in between them as r. And resultant is making an angle alpha with respect to x-axis. Clear? Now let us see the process, how to find out the resultant of these vectors. Let us have the clarity. This is a vector a bar. This is a vector b bar. This is origin, and the angle between them is theta. As I told you that the resultant is lying in between them. This is the resultant F, and it is making an angle alpha with respect to x-axis. Alpha with respect to x-axis. Clear? Now, to find out this resultant, I am making use of parallelogram law. Making use of parallelogram law. Okay, I am constructing a simple parallelogram. Now observe, this is b bar. Now I am dropping a vector parallel here. This is b bar. Okay. Now this is a bar. Now I am dropping a vector parallel here. A bar. So parallel to b bar. Here I have dropped b bar. Parallel to a bar. Here I have constructed a bar. Okay. Now this is a parallelogram. Clear? I am giving the naming words. Let us say O, A, B, C. OA, B, C is a parallelogram. OA, B, C is a parallelogram. Clear? Okay. Now, observe here. Suppose if I extend this OA, if I extend this OA along x-axis like this, okay, and drop a perpendicular, here from C to x-axis, C to x-axis. This is the perpendicular right angle here. Now, if I am giving this as some D letter. Now, OCD is a right angle triangle. Right angle triangle. OCD is a right angle triangle. Okay. In OCD, right angle triangle. Clear? Now observe. if this is theta, B is making theta with the x-axis. The same mathematical concept, the same B here also makes theta angle with x-axis. The x-axis. Clear? Now, I am interested to find out. In the triangle OCD, the resultant force F. The resultant force F. What is the resultant? Resultant F is nothing but here. F is nothing but here. OC square, which is equal to OD. Base is OD and CD is height. OD square base is plus CD. CD is height. CD square. That means if I want to know OC, that is F resultant, I must know OD and C, such that OD square plus CD square is OC square. Provided if I know OD and CD, then I can easily find out in this right angle triangle OCD the quantity of resultant F. Clear? Now, observe what is OD? What is OD? From this right angle triangle, what is OD? Observe here. OD is OA plus AD. OA plus AD. OA plus AD. Clear? Now, observe. For your clarity, I am drawing the triangle again once again. This is x-axis. This is y-axis, origin. Here, this is origin. This is one of the vector. That is A bar. B bar. This is another vector. That is A bar. Angle between them is theta. The resultant is F. Now, I have drawn a parallel mechanism here. Okay. I have drawn a parallel mechanism A bar formed as a parallelogram. Now, this is making alpha, resultant is making alpha angle with respect to x-axis. Now, I dropped perpendicular over here. Okay. And this is also theta. Now, I am giving the notations O, A, B, C, D. A, B, C, D. Now, I told that OD is OA plus AD. OA is what? OA is A. A plus A. AD is what? Again, observe. In triangle, rectangle triangle, CAD. CAD. In the right angle triangle, CAD. CAD, this is a right angle triangle. I want to find out AD. When I want to find out AD, okay, I take cos theta in this. Cos theta is adjacent side AD by this. What is this? This is parallel to this AC. AC. So this is nothing but AD by AC is how much? AC is B bar here, parallel. So, so AD becomes cross multiplying these two B bar cos theta. B bar cos theta. Okay. Now I'm substituting here. AD is B cos theta. AD is B. So that OD becomes A plus B cos plus B cos theta. Is it clear? OD becomes A plus B cos theta. Okay. Now, in the earlier, in triangle, right angle triangle, OCD, I am interested. Resultant OC square. Resultant square is, that is OD square plus what it is? This was the, I am drawing here. This was, so this was the triangle. This was the triangle. I'm giving the name O A. This is C. This is D. So this is a right angle triangle. This is theta. This is alpha. This is also theta. So OC square is OD square plus CD square plus CD square. Clear? CD square. What is OD? OD just now we have calculated. A plus B cos theta. A plus B cos theta. Plus CD. What is CD? Observe CD in this right angle triangle. If I take in triangle CAD, if I take sin theta is opposite side CD by hypotenuse AC. Now CD I am interested. CD by AC is how much? AC is nothing but the vector. How the clarity? It is A bar is this vector, B bar is this vector. This vector is parallel B bar. So this is nothing but B bar. So CD is nothing but CD, here I am writing directly B sin theta. B sin theta. Clear? Now I am expanding these terms. A square, A plus B whole square, A square plus B square cos square theta plus 2AB cos theta. A plus B whole square formula, 2AB cos theta plus B square sin square theta. B square sin square theta. Now, OC is what? OC is nothing but F here. So F square is equal to S square. Observe, in this case, in this term, B square cos square theta, B square sin square theta. Common is what? B square. So B square is a common. So B square sin square theta plus cos square theta plus 2AB cos theta. 2ab cos theta. Okay. You know very well that sin square theta plus cos square theta, how much? 1 from trigonometry. So this becomes finally f square is a square plus b square plus 2ab cos theta. So f is nothing but a square plus b square plus 2ab cos theta under root. This is the resultant of two vectors acting an angle theta between them. Theta between them. Clear? And be careful. Where A is the magnitude of the first vector A bar, B is the magnitude of the second vector B bar. Similarly, A is the magnitude of first vector A bar, B is the magnitude of the second vector B bar. Theta is the angle between them. Theta is the angle between them. This is resultant force. If two vectors are given at an angle theta between them. Okay. Now I need the direction also for this. I need the direction also. Direction of resultant vector F. Resultant vector F. Clear? Now observe. This was given like this. This was A bar. This was A bar. This was B bar. Theta is in between them. And this is the resultant F acting at an angle alpha. Now we constructed a parallelogram B bar parallel to the, and we have constructed again parallel to this A bar we have constructed. Okay, now we have drawn a perpendicular here extending this. We have drawn a perpendicular, and this angle is theta, then this angle is also theta. And we have given the naming of the triangle. We have given the naming of the triangle. That is O, A, B, C, D. Now, what is the direction of this resultant vector? Direction of the resultant vector is nothing but alpha angle with respect to x-axis. Now, in right angle triangle OCD. Again, I am making use of the same right angle triangle OCD. What is tan alpha? And because I require the alpha angle, direction angle of the F with respect to x-axis. Tan alpha is in this triangle, tan alpha is opposite side CD by adjacent side OD. Adjacent side CD by OD. What is OD from the earlier? OA plus AD. OA plus AD, the OD. Clear? Now, what is OA? Earlier we have calculated OA is A. See this? OA is A. And AD is what? This AD corresponds to the B cos theta. CD is what? This corresponds to the B sin theta. Earlier we have calculated these two things. We have calculated these two things. V sin theta. This is V cos theta. Substituting simply here. Okay. Now tan alpha is equal to tan alpha is equal to clear in right angle triangle. Again, I am writing in right angle triangle OCD OCD. Yeah, this is CD by OB, and this is CD by OA plus AD, and tan alpha CD is B sin theta. OA is nothing but A plus AD is B cos theta. So finally becomes alpha is tan inverse of B sin theta by A plus B cos theta. This is the direction. This is the direction of resultant. Resultant. Yeah. With respect to x-axis. Okay. Now, we have found resultant as well as direction in this case. Okay. Hope you have understood these things. Please go through carefully once again through the video. You can easily understand it. Since in the diagram, slowly you can understand, have the clarity, then you can easily understand this. Yeah. If you like the video, please subscribe it. And thank you.